learning goal today is pretty basic.
See? Just happened.
I can add and subtract polynomials. Okay? So you're going to be adding and subtracting, but in reality, what we're going to do with our subtracting is we're going to change it to add the opposite like we do with everything else. So, okay, so to add or subtract polynomials, what we need to do is we need to combine like terms. Okay, so we combine like terms, which you practiced in your warm-up after your quiz 6.2, was it? I think it was. 6.2 is the last quiz you took, and you did that assignment. The polynomials will be written in parentheses. In other words, you'll know what the polynomials are that you need to operate on. They will be in parentheses. It'll say this is a polynomial that needs to either be added to another polynomial, or maybe there's going to be a subtraction between them, and they show you the polynomials by putting them in parentheses. We are going to change our subtraction to add the opposite to help us be successful. And then I'm going to show you two different ways that we can add these polynomials. So even if they were subtraction, after we've changed them to add the opposite, we can either add them vertically, the way we're used to adding, like triple digit numbers. Maybe if you add a triple digit number to another triple digit number, you line them up vertically. You put one on a line, you line up the other one underneath it, and you add down, right? You do the vertical. Or horizontally. Today in our notes, when we're practicing together, we're going to do it both ways. But then when you get to your homework, if they don't tell you which way to do it, you get to choose. Which way do you like better? But we're going to practice both ways in our notes so we know both ways to do it. Okay, number one. How many polynomials do we have to add together here? How many polynomials are there in number one? Look above and see what we set up above. The polynomials will be in what? Parentheses. So how many polynomials do we have here, Calvin?
All together?
All together, number one. How many polynomials are there?
Just two.
Just two, that's right, just two. We have this polynomial right here, it's in parentheses. What kind of a polynomial is it? Would you classify that polynomial for me, please? Let's get some practice in that also. Faith, what kind of a polynomial is that? Got that memorized yet? No? Anybody think they know what kind of a polynomial that is? Oh, you got it? What is it? It's a trinomial because it has three terms. What else it has to have? That's its last name. What's its first name? Quadratic because it is
degree of 2.
Degree 2. Yeah, it's a quadratic trinomial. Yeah. So we gotta stay in the habit of being able to name polynomials also, because there's going to be some things that we'll do with just knowing the name of it that will be helpful to us. And then we have this polynomial, the second polynomial, because Calvin said there's two of them. Here's our second one. And what kind of polynomial is this one?
This trinomial.
It's a quadratic trinomial also, isn't it? It's a degree 2, and it has 3 terms, so it's a quadratic trinomial also. So we have two quadratic trinomials are going to be added together. Let's do the vertical format first. So we'll write down our first one, and we're going to change the subtraction inside of it to add the opposite. So instead of a minus 6x, it's going to become plus a negative 6x. And then vertically means we're going to line the other one up underneath it. So we're going to have negative x squared plus 4x. We have a subtract 5, so we'll change that to plus a negative 5. And if you did it like I did it, you should nicely see that you have some columns of like terms. And put a big plus sign over here. We're going to add those two together. So it's just like a 3-digit number. When we add down in columns. but this is a little bit different because we don't do any carrying or anything like that. We just add like terms and we have to bring addition signs down. So we can start on the left and work our way across to the right, or we can start on the right and work our way back to the left. It doesn't matter. Let's start on the left. 3x squared plus a negative x squared. What is that?
2x squared.
3, remember you can stick a 1 in here, right? So we have a 3 plus a negative 1, that is 2, and those are x squareds. We're adding. When you add terms, they stay what they were. Just how many are there of them now? Bring down the addition sign that's between those next ones, and we have a negative 6x plus a 4x. Negative 2x. Bring down the plus sign that's between them. So it's kind of like this right here is coming down. This right here is coming down. 2 plus a negative 5. Negative 3. And now we clean that up. What would that look like cleaned up? 2x squared
Minus 2x.
minus 2x minus 3. There's the sum of our polynomials. But we have to keep addition signs between our terms, otherwise it becomes a multiplication problem instead. Okay? Okay, horizontal format, now what we do is we take the 3x squared and change our subtraction to add the opposite. And same thing in the other one, change any subtraction to add the opposite. Now, because it is addition of polynomials already, it started out as addition. And what I mean by it starting out as addition is this addition sign between the two polynomials, it's addition of polynomials. So because once it's addition of polynomials, we can ditch those parentheses. We can just say, you know what, when we're doing, just like here, we ditched them over here. When we set them up vertically, we're going to ditch them here when we do it horizontally. So we're just going to say, I can take that 3x squared and that negative 6x and that plus 2 and that negative x squared and that 4x. And notice there's addition signs happening between all of them. We had 6 terms altogether because each polynomial had 3. 3 and 3 is 6. So we should have 1, 2, 3, 4, 5, 6 polynomials in our horizontal line. Now we're going to rearrange them so like terms can get grouped together, can be brought together. So x squareds are going to come to the front of the pack. So the 3x squared plus the negative x squared. The x's would be next, plus negative 6x plus 4x. So it's almost like what you could do is you could put a box around these guys and say, we're just grouping together like terms here. And now our constants can come together. So this silly looking thing here is a negative 5. So we're just regrouping them, reordering them so that we can put like terms beside each other, is what it amounts to. And now we're just doing the same thing we did when we did it vertically. We say we have 3x squareds, added with a negative 1x squared, what do we have? 2x squared. Bring down the addition sign. 6x plus, or a negative 6x plus 4x. Negative 2x plus 2 plus negative 5. Negative 3. Again, this cleans up to the same thing that we got when we did it vertically. So it's the same answer, just a different method to get to it. Right now, do you think you have a favorite? Which one? Well, it's easier, isn't it? Probably a little bit less work. Okay, anybody have any part of that though that you're confused on? You'd like, could we just stop and talk about that for a bit?
in the elementary one is to label
No, you don't have to. You don't have to state which one, just in our notes. Yes, Clara?
And every problem that we have, like, any problem with these that we're doing, can we only, like, say if we like doing vertical, can we always do it in vertical?
I'm gonna look at the worksheet right now and see if it ever tells you, if it ever says you have to do it this way. First set of instructions say add. That's all they say. Second set of instructions says subtract. That's all they say. Third set of instructions, each of them have their own, they don't tell you. Now, what I will tell you is the first three are lined up like vertical, so you're probably gonna wanna just keep them like that, right? The next two are not, they're lined up, kind of how they started here, and then you can decide. Okay, so it kind of looks like sometimes they kind of decide for you, they've already kind of got it set up for you, and other times you get to make the decision all on your own. Anybody else have any other concerns, questions? Okay, then let's move on to this next one. What's different with this one?
Subtraction.
It's subtraction, okay? It is subtraction. So the first thing we're going to do is we're going to change any subtraction within the polynomials only. It's the only thing we're going to do. We're going to leave it as a subtraction problem in between here. We're not going to change that. That's going to stay. We're just going to say, are there any subtractions within the polynomials that I can change to add the opposite? So 4a squared will stay 4a squared. We do have a subtraction here, so it's going to become plus what?
negative 8.
Negative 8a. And then that one's addition, so we'll just leave it plus 3. The other polynomial, and this is a really, really important step, you guys. Okay? Just change the subtractions within the polynomials. So we have 7a squared plus 2a plus negative 2. Now, why that's so important is because order matters in subtraction. So the first thing we got to do is we just got to clarify what's going on within the polynomials first. And then we say, okay, that first polynomial has to be the start. And from it, I need to subtract the other polynomial. So which polynomial, when we change it to add the opposite, is going to change names? The first one or the second one? The second one has to change. So this one, the one that starts the subtraction problem, we don't mess with it. It stays 4a squared plus negative 8a plus 3. Don't mess with it. But to be able now to change this subtraction, now we're ready to take care of this subtraction, we're going to change it to addition. But when we do that, every single one of these terms, because that whole polynomial needs to be subtracted. So every single one of those terms has to be changed to its opposite. So the first term will now be what? Negative 7a to the second plus negative 2a plus positive 2. Don't try to do too much at one time. In the first step, change the subtractions within the polynomials themselves. Then, in the next step, when it's a subtraction problem, change the subtraction to addition and all of the terms of the second polynomial to their opposites. And now you're ready to set up the vertical or the horizontal format. Okay, I'm going to let you pick which one you want to do. Go ahead and do whichever one you saw both of them. I'll do them both, and you can do the one you want. and we should all get the same final answer no matter which format we use. How many of you use the horizontal format? Okay, get the same answer. Okay. And that means the rest of you use the vertical format? Get the same answer? Okay. So you get to choose, especially when it's set up already in horizontal, then that's definitely the time it's easiest then to really make the choice. Do I like vertical better or horizontal? Okay. So in the horizontal one, the first step, I just drop the parentheses. You cannot drop parentheses until it is a complete addition problem, right? You cannot drop parentheses in polynomials until it is a complete addition problem. There is not a subtraction sign in it anywhere anymore. Then you can drop the parentheses and go to work either setting up the vertical format or the horizontal format. Okay, let's go to the back side then. I think we have couple more that we're going to practice here, because sometimes they don't have the same number of terms, and sometimes they're not even the same degree. So notice the first one is only a 2-term polynomial. It's a degree 2, but that makes it a quadratic, instead of a quadratic trinomial, it's a quadratic what? 2 terms. Binomial. And the other one is a 3-term, and it's a degree 2, so that one's a quadratic trinomial. Now we're working with polynomials that aren't of the same type. They don't have the same name. So let's just see what happens though. What are we going to do? First thing we're going to do is we're going to change any subtraction within the polynomials only. And so this one can become plus a negative 1n, right? Leave that subtraction in between the parentheses alone for right now. Don't mess with it. Are you with us, Calvin?
Yep.
Okay, and then any subtraction in this polynomial we will change also. And notice we're not getting rid of the parentheses because we're only taking care of the subtraction inside the parentheses for the moment. And the subtraction in between them stayed. Now we can change this subtraction to addition by changing every one of these to their what? Opposites. So what will this new polynomial's name be now? Class out loud.
4n squared.
Thanks, Aurora. Class
Plus 3.
plus negative 5. That one changes because it's add the opposite. Does this one change? No, this one stays like it is. Leave it alone. Don't rename the first one. Now we decide. Now, we're going to do both of these together, okay? We're going to do them together. So, this one has a 2n squared plus a negative 1n. What's it missing that the other one has? It doesn't have the... Okay, let's think of it. This was going to be a quadratic trinomial. What piece would it need to have to be a trinomial?
Another variable.
Not a variable,
Term.
just another term, and that term would be a constant, just a number, right? Okay, so since it doesn't have that, we're going to call we're going to put in there what's called a placeholder. We're going to put a +0 in here. When we're adding vertically, we need placeholders. Okay, so since it was missing the constant part of the trinomial, we're going to have to put that placeholder in there. And now when we line up our other one underneath it, it has all 3 terms. It doesn't need any placeholder. Okay, so go ahead and add that one vertically. Get the sum of this one. And then clean it up if it needs cleaning up. Do you agree with me after you've done getting your sum? And cleaning it up? Okay, when we do it horizontally, this might be the one time that you say, you know what, when they don't match, when they aren't both the same type of polynomial, maybe I like horizontal format better. Because then when you do horizontal format, first of all, we can just write them down, ditching the parentheses. And we're only going to have 5 terms because one of them had 2 terms, the other had 3, so altogether it has 5. We don't need placeholders when we do it horizontally. We just need to group like terms together. So we say, well, we got n squareds here and there, so we'll bring those guys together at the front. Plus, well, we got some n's. We got a -1n and then a 3n. So we'll group those guys together. And then we only have the constant -5, so it doesn't have anybody to be added to, so it just gets boxed by itself. So you know what? I'm wrong. We don't need a placeholder for that, because we're not trying to add in columns. Okay, so then when we take our groups and simplify them, we end up with the same result. So typically, if I tend to lean towards using the horizontal format, it is in ones where the polynomials don't have the same number of terms and they're not the same degree. They don't have the same name, basically. Then I say, you know what? I think I want to do it horizontally this time. So we go back and forth between vertical and horizontal. Okay, so now let's look at that next one. Is it a subtraction of polynomials, first of all? No, it's not a subtraction of polynomials. So that means we're not going to have to worry about changing the subtraction in between them. But we do first have to do what? Add the opposite for wherever there are subtractions. Well, the first polynomial certainly has a lot of subtractions, so x cubed plus -x squared plus -x plus -1. The only term that didn't have to be renamed in that one was the first one. Do we have to rename any of them in the second polynomial? No. Okay, so x squared plus x plus 1. Okay. So it's kind of like I did the changing the subtraction to add the opposite. We only had to do it in the first polynomial, but we just rewrite the rest of the problem, break it down. Now, we look at them and say, are they the same type of polynomial? No. The first one is a what degree? Cubic. And it has how many terms? 4. Is there a special name for a 4-term polynomial? Just a polynomial, right? So it's a cubic polynomial. How about the second polynomial? What kind is that? A quadratic trinomial. So we got a cubic polynomial that wants to be added to a quadratic trinomial. Are they, so if we use vertical, what are we going to have? We say to ourselves, if I'm going to use the vertical format, I'm going to have to use placeholders. If I use the horizontal method, do I have to use placeholders? No. Okay, so go ahead. Do the one you want to do then. I'll do them both. I got a cubic monomial for an answer. So when I added it vertically, I needed a placeholder in the second polynomial for the x cubed. I just put a 0 there. Good when you add 0 to something, what happens? Does it change it? No. Okay. Michaela?
How do you know which, where to put the 0? Because I put it under the -1 and then you put it there.
Right. So what you did is you lined it up, so you said, this is what I envision is happening on your paper. And then I'm just going to show the placeholder with black. Am I right?
Mhm.
That's how you did it? Okay. Now, when we're adding vertically, putting the placeholder underneath the -1 is that useful? Because here's the deal. What do we want to happen in our columns?
Unbeeline.
We want these columns to have like terms. Okay? These guys have like terms because 0 is a like term with anything. Are these guys like terms? X's are not the same as a constant. These are x squareds, these are x's, these are x cubes, these are x's. It's the same way as this, Michaela. If I asked you to add 6,742 and I asked you to add 359 to it, would you line it up like this? No, you wouldn't, would you? Because you want the 3 to be in the hundreds column and you want the 5 to be in the tens column, don't you? Yeah. Except what we do is we do not just stick a 0 in front of it. Typically, we just leave that place blank, don't we? But could we put a 0 here? We could, couldn't we? Yeah. So think of it that way, that you need things to be lined up that are like each other. So that's how you decide where the placeholder should go. So when you're setting it up, if the things don't line up, then you got to erase and say, I can move something a different direction, and I can put things so that they're going to line up in columns, and wherever there isn't something, I'm going to put a placeholder in, I'm going to put a 0 in, okay? So, good question, because that can happen. And then in this one, when you rearrange them to group them together, the x cubed doesn't have anything to be in its group, right? And what happens when you, what relationship do those guys have to each other? What can we call them? Not only like terms, but what else? Opposites. And what happens when you add opposites? What do you get? 0. Yeah. So when you add opposites, you get 0. These are opposites too, aren't they? And these guys are opposites too, aren't they? Yeah. We have lots of things that become opposites and they cancel each other out or they become 0. And that's why we just end up with that one-term answer of x cubed. Okay? So any other questions on this? Okay, then why don't you, I think you should get out a sheet of loose leaf paper.